Hi, in this video we are going to talk about tree set in Java. Tree set is mainly an implementation of self-balancing binary search tree. It supports operations like search, insert, delete, which are similar to hashing. But with hashing, you don't have other functions which are there in the tree set. The other functions are floor, ceiling, lower, higher. Not only this, when you traverse a tree set, you get the items in sorted order. Let's take a look at this program. We have created an object of tree set, which is a tree set of a string. And by default, the elements in tree set are ordered by the default order, which is increasing order. For strings, it's lexicographically increasing order. And please remember, it has to be a non-primitive type, right? It can't be int. If you want to create a tree set of integers, you will have to use integer wrapper class. We have added 3 items to the tree set. So the function to add or insert items in tree set is add. Function to check whether an item is present or not is contains. And function to remove an item is remove. We'll see an example of remove soon. So when you print the tree set, you get the items in sorted order. Let's write down the output of this program. We'll get courses first. Then we'll get GFG. And at the end, we'll get IDE. We get all the items in sorted order when we print the tree set. Now we are checking whether this tree set contains IDE or not. So contains function returns true if the past item is there in the tree set, otherwise false. So we are going to get true here. And this is where we iterate through the tree set. We have created an iterator. This iterator function of tree set gives you the iterator of the tree set. Has next function checks whether there is a next item in the tree set or not. And next function prints the next item. So we are going to get all the items of this tree set again in increasing order. We'll get the courses first. Then we'll get GFG. Then we'll get IDE. Like hash set, if we try to insert an item which is already present in the tree set, the add function ignores this item. It does not enter duplicates. For example, if I enter IDE again, what will happen? IDE would not be added. I'll still get the same output if I get a line s.add IDE or any of these 3 things which are already there in the tree set. Let us now talk about one more example of tree set. In this example, we have mainly discussed remove, and we have discussed one more way of traversing through the tree set. So we have added integers this time. We have created a tree set of integers. When you remove 5, 5 is gone and remaining items are printed in increasing order. And this is for each loop to traverse through all items of a tree set. So what you will get as an output, you will get 2, then you will not get 5 because 5 is removed, then you will get 10, then you will get 15. Here is one more example, and these functions are not present in hash set. They are only in tree set. Lower function gives you the largest value which is lower than the given value. So you will have output as 2. There is only one lower value. Suppose there was one more lower value 1. Even then output would have been 2 because 2 is the largest of 2 lower values. Higher gives you the smallest higher value. So there are 2 higher values, 10 and 15. The smallest of these 2 is 10. Floor gives you the value which is smaller or equal to. So 5 is present, so we are going to get floor as 5. Ceiling gives you the value which is greater than or equal to, so we are going to get 5. Now if these values don't exist, then these functions return null. For example, if I call lower for 2, there's no value smaller than 2, I'll get null. If I call higher for 15, I'll get null, or any value greater than 15. Similarly, if I call floor for 1, I'll get null. Ceiling for 16, I'll get null. So if these values don't exist, then these functions simply return null. Let us now talk about time complexities of different operations. Since it uses red-black tree, so operations like add, contains, remove, floor, ceiling, higher, lower, they all are log n. We can always perform these operations in log n time in a red-black tree. And the operations like size is empty, they are big O of 1. Because size is maintained internally in the container, so you can just get the value of size, and by getting the value of size, you can check whether the container is empty or not. Tree set is an implementation of self-balancing BST in Java. So wherever you feel like you need to use self-balancing BSTs to solve this question, like finding ceiling of every element on left side, or finding ceiling on the right side, or finding floor on the left side, or finding floor on the right side, for all these questions, we need tree set, and we can directly use it instead of making our own self-balancing BST. In this video, we have talked about tree set, its main functions and their time complexities. Tree set supports many more functions, like there's a function called first, which gives you the lowest key. There's a function called last, which gives you the last key or the highest key. There are more functions like hat set and tree set. Hat set gives you set of smaller keys. Tail set gives you the set of larger keys. And there are more functions. But in this video, we have talked about the most used functions in tree set.